Good afternoon, everyone. Yeah, I think now it's fine. I head digital and IT at Aditya Birla Fashion and Retail. I don't know whether you know Aditya Birla Fashion by its name, but essentially all our brands, I'm sure you're heard of. Brands like Pantaloons, Louis Philippe, Van Heusen, and now new brands, recent acquisition like W as well, Aurelia, and also now Sabyasachi and Tarun Teliani and Masaba and so on. So multiple different brands in all formats of retail. Of course, limited to fashion retail. I think Ajay requested me before we start the panel discussion to maybe give a brief uh, overview of where AI has a role to play in supply chain. Uh, Now here, when I'm going to talk about AI, I'm going to use it a bit in a broader sense. There are a lot of things. What is AI? Whether it's Gen AI or is ML AI or not. But I'm not going to get into that controversy. So when I'm using the word AI, I essentially mean all the way from advanced analytics to machine learning to the general AI to generative AI, right? All those categories, right? And and essentially where we are using algorithms, right? Where we are using some kind of algorithms to in supply chain. So with that broader context, let me talk about what are the use cases typically in supply chain that are getting influenced by the whole AI revolution. Now, again, when you look at supply chain, in general for retail, there are probably only two things. There's a front end, which is the customer front end, which can be online, it can be offline, stores or e-commerce or a mix of the two, omni-channel and so on. And everything else is really the back end in terms of product design, product creation, manufacturing, uh, product movement, supply chain on the product, as well as post movement liquidation, sustainability initiatives around that, disposal for what is not sold. So that whole really constitutes the back end, which is again, in some ways part of the entire supply chain for retail and particularly fashion retail. And here, I think the problem that retailers face in terms of managing this backend, and especially at the scale that we operate in, right? Now, in fashion, of course, the problem is a bit different from, let's say, grocery, or some other form. For instance, in fashion, the product is not the same. Our product changes nowadays every month, right? We are creating new designs every month, dropping them, and those drops have to happen across a 4,000 store network. The designs have a life of only 5-6 months. So that's in fashion. But in some other retail format, in a grocery, just the amount of SKUs can be very large, right? And if it's quick service grocery, then the challenge is to make sure that what is consumed by the market in a particular location, in a particular catchment area, is available at that local stocking point, right? So that itself becomes a challenge, because you can't store everything that is in your catalog at each and every place. And same is the problem for us, right? We may have a store of 1,500 square feet. One particular store cannot have all the styles that we may launch in a particular season, right? So you have to be selective about what you put in which store. And what should be the mix of sizes, and what should be the depth that you hold in a store. So all of this makes the supply chain very complicated. So a combination of the number of SKUs, the time of delivery, I mean, which is a big factor in terms of how soon you expect to be servicing a particular order. It can be real time, as in a customer walking into a store, or it can be a quick commerce, quick service delivery, or it can be maybe same day, next day delivery, hyper local kind of model. So the ability to deliver quickly, so having that inventory available at a point near the customer, right, as well as the limitations of physical storage, whether it is in a store or whether it is in a stocking point closer to the customer. So all this, essentially, it's a very complex problem which cannot be solved without algorithm. And let me put it that way. I mean, it's not about whether AI is used or not. These are problems which earlier people used to manage in some way, not very efficiently. But the moment you're trying to drive efficiency around those, the only way you can deal with them is by using some kind of automation algorithms. Now, here in supply chain, typically there have been two approaches to how do you optimize your supply chain. And the purpose of this is essentially, broadly, let's say there are two objectives. One is how do you make sure that you have the right product available at the right place, at the right time, right? So that is one part, so that you don't lose sales, right? So in most cases, that's your primary objective, right? You want to make sure that you maximize your sale, so making sure that the product is available at the right place and right time. Second part is your supply chain inventory holding cost, right? So it's a trade-off between making sure that you maximize sales while minimizing inventory or working capital in your supply chain. And again, I will not be inventory plus, let's say, inventory you may hold at a vendor or whatever, stock held at the vendor where you're not paying for, but whichever way, essentially minimizing your working capital. So those are the two metrics that you're driving for. One is, maximizing sales with the constraints, and then, minimizing inventory. Now, and to be able to do this broadly, the two approaches that people take, one is that you try to be accurate in your demand planning. So if you have a good handle on demand, then you can plan your supply to align with the demand. And the second school of thought is demand you cannot plan, so it is always going to be very variable, and there's no point wasting time trying to do demand planning. So simply compress or shrink the supply chain so that you can respond quickly to the demand. Right. So those are the kind of two models or approaches people have taken to run their supply chains, and both work. And again, a lot depends on the nature of the product. Where the product is same, in grocery or electronics, the demand pool model can work well. So core products where the SKUs is not changing, demand planning can work well. In fashion, typically, demand planning doesn't work well because your product is changing. So you may be able to forecast demand at an aggregate level, at a category level, but you cannot get it down to an SKU level. But your supply planning has to be done at an SKU level, so that becomes challenging. However, if you're in fast fashion, and I'm sure all of you have heard of Shine, though they are not present in India, right? Their whole approach to supply chain planning is simply, find out the trend, produce in line with the trend, and shrink your supply chain so that you have the product out in, and of course it's a full e-commerce, so have the product out for customer in a matter of weeks, and keep changing your product so fast that you never run out of, you're never in a situation where you have obsolete inventory, right? So just make to the quantity that is needed, and a very flexible supply chain, as in factories which can produce what they want. But now that works well in, let's say, printed apparel and things like that, where you can keep some base products in your stock and print based on whatever is coming up. But it will not work with other kinds of fabric, woven and so on, where especially where you have long lead times on supply of fabric. So where you're locking in supply of fabric, that may not work. So in which case you have to try to see how best you can optimize between shrinking the supply chain and getting better at demand forecasting. So demand forecasting in fashion particularly becomes very complex because since you cannot forecast at the SKU level, at a broad level you can forecast, then can you use attribute data and market trends and probably look at getting better in terms of assessing demand for a particular style and using that to define your buy or your supply. Again, AI has been used. A lot of retailers have gone through that cycle, put in AI algorithms in order to do that. Product creation, I think that's one place where in fashion has really shrunk by the use of Gen AI especially. Today, even in our case, a lot of our designers are able to use AI to simply do product creation, right? Create their designs using out-of-box tools like Midjourney and DALL-E and so on. So the time it used to take to create multiple designs, which used to run into weeks, is now in hours, literally. So you're shrinking the design part. Similarly, in terms of product creation, sampling, for instance, instead of doing sampling, which is done with physical product, you may do sampling with digital product, right? Generate the 3D garment using AI tools and use that to get your sampling done without having to produce. So shrink the time for sampling. So different stages, different kinds of tools have got used to shrink the supply chain. And the demand planning, various algorithms, we choose attribute data of products and try to match it with market trends, and then predict whether certain products will succeed or not. What is likely to be their rate of sale, and using that to define your demand. So those are broadly the areas, and I'm sure the panel will have a lot more things to talk about as we have a mix of people from different lines of retail. So look forward to a better interaction as we go through. Thank you.